thermal mass is a kind of funny sounding term for what basically means heavy stuff. Thermal meaning heat, mass meaning the weight of something. But what it really means in the context of a green home is where can you put heavy materials and take advantage of the fact that they take longer to heat up and cool down than something which has very limited thermal mass. An example is coffee cups. This cup has thermal mass. This cup has very little thermal mass. So when you pour boiling water into this, quite a lot of the heat from that water goes into the cup and it will instantly cool that cup of tea down to the point that you can drink it. When you put boiling water in one of these, this does not absorb any of that heat. This thin paper, it has low thermal mass, doesn't absorb any of that heat. So there's more heat within your coffee. So when you insulate it by putting this lid on, which also traps the heat, then that's why 5 minutes later you take a sip and burn the top of your mouth, whereas this particular one, you wouldn't. So here we are at the Flannery Centre, and we're looking at some of the design aspects here relating to thermal mass. If you look at the ground that we're standing on, I'm standing on concrete, which is something that has a high thermal mass. Right next to it, we have Sydney Blue Gum timber floor, which has a low thermal mass. The impact of that can be readily seen using this temperature sensor. So if you look at where the sun is not shining on the concrete slab, it's about 20 degrees. Where the sun is shining on the slab, it's heated up to 24 degrees. Over here on the timber itself is where there's no sunlight, 23 degrees, and where the sunlight is, it's 29, well, there you go, nearly 30 degrees. So what's happening there is that this heavy material is absorbing more of the sun's energy and taking longer to heat up, but also that heat will take longer to release in the night. The timber is heating up really quickly to the sun, but equally cooling down really quickly as well. So it doesn't have that use overnight that perhaps the concrete does. Now let's go and have a look at the rammed earth wall. We've come into this classroom to show one of the popular misunderstandings around thermal mass, which is that people think it has to have sun shining on it to be useful. It's actually not the case, particularly in summer. This wall here is a standard timber frame plasterboard clad wall. This here is a Besser block Caulfield concrete wall. And you can see this one is about 20 degrees, 20.4, there you go. Whereas the lighter constructed timber one is 21, just over 21 degrees. So we are now at the middle of the day. The sun's been shining into this room and it's been heated up in the morning. And so you can see this lighter construction is already at the comfortable temperature from the room, whereas this wall is still cool from overnight. So it's still slowly heating up. Now, whilst that's a drag on the room at the moment and actually requires your heaters to, I guess, work harder to heat that up now, it does have a really positive impact in summer, because you can imagine you don't want this room to be hot, so this wall is absorbing the heat out of that space, and this one is just pretty much reflecting it straight back into it. So in summer, this wall, this heavy thermal mass wall, is really good at conditioning the space. And also the other thing in winter now, even though it takes quite a while to warm up, overnight it takes a long time to release that heat. So in this building, overnight the temperature will only drop down to about 17, maybe 15 degrees, whereas if you didn't have that sort of thermal mass in here, the building would drop down to 10 or 12 degrees in this environment. One of the other things to consider with thermal mass is whether you cover it or not. And basically, the golden rule is as soon as you put something on it, you diminish its impact and its performance for that space. Ideally, a concrete polished floor in a cooler climate with sun shining on it and then releasing that heat is the most efficient use of that thermal mass. However, there are places where you don't want to have concrete floors, like this classroom. So we've got carpet on the floor. Interestingly enough, it's made out of cornstarch. It's 99.9% recyclable and has low volatile organic compounds. So it's one of those kind of environmentally friendly products. But it's interesting, if you look at it here with this temperature gun, you can see It's 19.4 degrees there, which is the same temperature as the exposed concrete out in the other area. Where the sun's shining on that, straight away you're reflecting more heat into the room, 24.2 degrees. So it's still working because of the design of the building, even though it has been covered. So it's still contributing positively to the way the space functions.